Hi, my name is Bernie Wagenblast, your moderator for today's panel discussion, brought to you by Opticom Traffic Signal Priority Control Solutions. Before we get started, we'd like to welcome the transportation personnel who are listening today. As the editor of the Transportation Communications newsletter, a former New York City DOT and Port Authority of New York and New Jersey employee, as well as being a New York City traffic reporter, I've spent my entire career working with DOT personnel and understanding how complex the world of transportation management has become over the years. From a citizen's point of view, we all see the massive road construction projects going on around us, but even more overwhelming is the art and science of managing the traffic signal operations to ensure traffic runs smoothly, emergency personnel are responding quickly, transit stays on schedule, and that our intersections are being maintained in the most efficient and effective ways. The extensive thought processes and long-range planning teams involved, compounded with the challenge to find available funding to keep our traffic systems updated in a troubled economy, makes this discussion an interesting one for all municipalities going through these types of challenges themselves. Today, we're excited to have a group of panel members who will be discussing the forward thinking the city of Olathe, Kansas has done around bringing intelligent software to their city's traffic signal priority control system, and how a successful implementation changes everything for the traffic division for the better. So, without further ado, I'd like to introduce our panel. Like Dorothy and the Wizard of Oz, you may not be in Kansas, but today's keynote panel member is. His name is David Kumke, Traffic Signal Operations Supervisor for the City of Olathe, Kansas, and President-elect of IMSA, the International Municipal Signal Association. Welcome, David.
Thank you.
Next, we have Dan Wright, owner of Mid-American Signal, whose company assisted the City of Olathe with the implementation of the project. His input on the city's requirements and project timeline will give us an interesting perspective to better understand what agencies and their vendors need to think about when planning for a smooth implementation. It's good to have you here, Dan.
Thank you. Glad to be here.
And our third panel member represents the research and development perspective to design traffic signal priority control hardware and software that meets and or exceeds requirements for state and local agencies. I'd like to welcome Jim Malnati, Senior System Software Engineer for Global Traffic Technologies, manufacturer of Opticom, the leader in traffic signal priority control solutions. Welcome, Jim.
Thanks, Bernie.
We'll be breaking up today's discussion into three segments. The first, planning for preemption. The second, the implementation phase. And finally, our third segment, looking back and to the future. Let's get right to our first segment, planning for preemption. David, for those of us who aren't familiar with it, would you please describe the city of Olathe, Kansas?
Sure, Bernie. The name Olathe is actually a Shawnee Indian word meaning beautiful, although I wouldn't recommend trying that on your significant other. I tried it and it didn't work so well. But we are the second largest among 21 communities in Johnson County and the fourth largest city in the state. We're located approximately 20 miles southwest of downtown Kansas City. And from our earliest beginnings, we were a transportation hub, so to speak. Olathe is located where the historic Oregon, California, and Santa Fe trails cross. We have a population of about 125,000 people. I personally work within the traffic division, which operates as part of the Public Works Department. And we've been very fortunate to have some forward-looking leadership here in Olathe. There's a culture here that enables us to be on the leading edge of our professions. In fact, we're encouraged to be innovators and take risks. And this really enables us to work with some of the latest systems with the goal of increasing efficiencies, improving functional operations within the TOC and the ATMS system. Some of the items we've been working with include controller firmware, signal system software, Ethernet-based battery backup systems, network communications, and microwave detection systems. Being early adopters of different systems really has allowed us to be part of the solution and working with the manufacturers by suggesting or validating features or functions with their equipment. Our existing ATMS system affords us the opportunity to deploy and test some of the more leading-edge technologies.
Now, David, what are some of the biggest challenges that the traffic division in Olathe is facing today?
Well, Bernie, if you would have asked me that question 4 or 5 years ago, I would have said it would have been keeping up with the growing transportation needs of our community. For several years, we were the fastest growing city in the state. However, because of the economy, things have shifted. And now due to that, the revenue difficulties that all municipalities are feeling, our focus is really more on maximizing efficiencies on existing systems and trying to maintain a high service levels. which means we have to look for ways to do things smarter. The old adage of doing more with less is an axiom that government uses a lot lately.
Well, no doubt you've been very busy over the past decade or so, but could you give us a brief background of what some of the major projects the Olathe Traffic Division has been implementing over the past decade or so?
Sure. Our ATMS system has been a long time in the making, actually. We started from concept to acquiring funding and then into the design phase during the late 1990s. There was a lull in the action while trying to secure funding for the construction phases of the project, so after so much time had passed, really the leading edge had changed a little bit. We originally started with a sonnet ring topology for our network, and by the time we had funding for construction, Ethernet was starting to be more available in the traffic signal systems. So we had to make a last-minute change to adapt to that. We wanted to be on the edge of that system, and for implementation, the system took 4 separate construction phases. We began in 2004, and the final phase was completed last year. Currently, about 98% of all of our traffic signals are on our system. We were also a partnering agency in Operation Greenlight. They're a working group of our MPO, the Mid-America Regional Council. There's 26 partner agencies spanning across state lines. This was really a regional approach to moving traffic. Originally, we formed to ensure good progression from city to city and also trying to lower emissions, and it grew to include kind of a regional approach for our traffic system software. So the partnering agencies from the Kansas City region met to develop requirements. We had to assess needs and challenges of the various cities. And then ultimately, we met to select a traffic signal system software that met our needs.
Well, David, that gives us a good background of what's going on in Olathe. Dan, maybe you could tell us now how your company became involved with Olathe in the beginning and what some of the changes that were happening in the industry have been.
Sure, Bernie. Well, Olathe has been a customer of ours for many, many years, and we provided a variety of products, one of these being Opticom for the local intersections. Early on, 3M owned the Opticom product, and that was their brand. And it spun off and became Global Traffic Technologies, or GTT. GTT developed and released the Control Management Software, or the CMS software, and Olathe was one of the first to adopt and install the system.
Now, we've been talking about Preemption hardware. What exactly is Preemption hardware, and what does this central management software do?
Well, in this case, the Preemption software hardware that Olathe uses consists of an emitter on an emergency vehicle, a detector located out on the mast arm of the traffic signal pole, and a phase selector located in the traffic signal cabinet. These devices are used to optimize the response time for an emergency vehicle and a call. The central management system software gives the traffic department the ability to observe the intersection equipment, monitor the call activity at the intersection, and generate alerts and reports. This helps maintain a high level of performance for the safety of the vehicles that use the system.
Jim, anything you'd like to add?
Yeah, this is Jim Malnati from Global Traffic Technologies, or GTT. I mean, what Dan and David have described is a wonderful, reliable system, but, you know, with any system that has components, you really need to have a view of what's happening inside your system at a very deep level. And this is exactly what CMS is for. The central management software gives you this view of the system. Now, the best way to describe it is what it used to be and what it is today. It was a nightly polling of these components that would drive reports. So it was an offline reporting utility that, you know, David would use to look at his statistics, and that was good, but it was excellent users like him and others that pushed us to make it more dynamic and, in fact, real-time. So what we have today with this brand new release is really a game-changing capability that makes it a real-time monitoring system. So on a very regular basis, we're polling the phase selectors, looking for preemption calls, pieces that are not working anymore, like, say, an infrared detector, and we're alerting the people in the TMC. Now, the Traffic Management Center is a perfect place for this, but we can go beyond that, because if you have just a visual display, that's pretty good. I mean, people are watching it, but what if you're a signal tech out in the field and suddenly a detector goes bad on the other side of town? Well, CMS can actually send text messages or email to people's BlackBerries, let's say, the signal technician in the field can see that they've got a problem and get over and fix it immediately. And this really has changed things, because it used to be that people would have maybe an annual maintenance plan. That's good, but on a yearly basis, you're going to miss equipment, and it's going to sit there for a long time before it's found. Now we have a dynamic way of seeing what's going on behind the scenes.
Well, with all this, I certainly understand, David, why the responders need the green signal, but what were the key reasons that you started looking at the software?
Well, it's really offered us some opportunities to more effectively operate and maintain the equipment we have in the field. But not only that, it's the information, such as encoding schemes, the usage logs, timestamp functions. Now from the TOC, we can communicate directly with the equipment utilizing our ATMS network. We can monitor, troubleshoot, and maintain a high degree of operational uptime, which is important to us. And it's important to our fire and medic personnel as well. In their business, every second counts, and delays could cause loss of property or even life. And I've personally experienced this riding in the ambulance with my son from the point of pickup all the way to the hospital. We traveled through several different heavily traveled corridors, and we never had to stop for a red light. And so that there's a lot of value in that, and I've personally experienced it. But the features of the software has really saved us a significant amount of time in maintenance. We used to need to rely, just like Jim had talked about, on fire and medac contacting us to let us know if a particular detector wasn't working, or checking all of our preemption for proper operation was done also as part of our annual preventive maintenance plan. But now the system monitors detector noise for levels that can indicate a problem, and then they're displayed in the category. Like Jim said, they could be emailed out to technicians in the field. And when we installed the version with this feature, we were immediately able to detect and repair 6 problem detectors within the first day that without this system we probably wouldn't have been aware of. We can also view activity at each location, so we can dispatch a technician, and all they have to do is turn on their emitter and drive that particular direction. You don't need a second tech at the cabinet to verify the discriminators are working properly anymore. The activity screen tells us the encoded transmitter information, intensity levels, making troubleshooting much more efficient. And the active monitoring feature lets us know what intersections are being preempted, including direction, user, vehicle ID, and time, because we've all sat and probably experienced the negative side effects of preemption, and that is for the rest of the drivers. I know I personally sat there and you waited at a traffic signal and you wonder what's going on and you got skipped or something's going on. Well, we get a lot of phone calls here at the TOC regarding those type of usage issues, and we're able to actually look at the system and figure out if that was the issue and communicate that effectively to our citizens.